Yo, quarantine is messing with my mind. Woo. Like my hairdo? Took me all day. Took me all day to do this hairdo. Alright, so yesterday you did some graphing with exponential functions. We're gonna keep kind of going with that idea, but instead of doing the graphs, I just want to make sure, drill and kill, that you know the vocab with these exponential functions. Again, remember with this exponential function, the variable is now in the exponent, right? So you'll have a base with the variable as an exponent. Whereas the last chapter that we did with quadratics, the variable was the base and then the exponent was a number. All right, so make sure you're starting to notice those differences. This is an exponential function versus a quadratic function. And at the very beginning of the semester, we did linear functions where it was just x, all right, mx plus b. Okay, so getting into our parameters, the initial value, that is what is the first number, usually. It's also the number that does not have a variable to it. So in this first section here, 5 is your initial value. All right. It has a couple other names. It's initial value. It's also called A. It's also called the y-intercept. All right, so initial value, y-intercept, the A, that would be the 5. The B here, that's the base. The base is 2. So then the question is it growth or decay? That's based on the base. If it's a number larger than 1, then it's growing, right? You'll have exponential growth. If it's a number less than 1, like a half or a fourth or 0.2222222, that's also decay because it's less than 1. All right, so a base of 2, that would be growth. The asymptote, that's the number that's added or subtracted at the end. So right here we have an asymptote of 1, so we would say y equals 1. All right, so over here on number 2, initial value, it starts off with a 1/2. The base with the exponent is 1/6. 1/6, that's smaller than 1. That means this graph is decaying, so that would be decay. The asymptote is what's added or subtracted at the end, so that would be -2. Right, so on a graph at y equals -2, you'd have this invisible electric fence that the graph would get closer and closer into, but it won't touch it. Because if it touches it, that's not good. All right, same thing back on number 1. I didn't graph it. You would go to y equals 1, and that's where your asymptote would be. Right, that's that force field, the invisible line that you can't cross. All right, so then number 3, the initial value, 4. The base, 1/2. 1/2, that's less than 1, so we are decay. The asymptote is y equals 2. Check out number 4. The initial value is 5. The base is 1/2. Since it's less than 1, that means it's decay. The asymptote is at that -2. All right. Check out number 5. The initial value is 4. The base is 1/2. Since 1/2 is less than 1, that's decay. The asymptote is y equals -2. The initial value here, 1/4. Base, 6. Since 6 is greater than 1, that's growth. Asymptote, y equals a +1. All right, so let me give you a 10-second head start for 7, 8, 9, and 10. That's my daughter. All right, so maybe I should do my hair like this. Babushka. Boo! All right, so let's see how you did. All right, number 7, initial value is 2. Base is 1/3. That would be decay because it's smaller than 1. The asymptote is y equals 2. All right, initial value here is 4. Remember, initial value is also the A. It's also called the y-intercept, so this is where it crosses the y-axis. The base is 2. So that means it's growth. The asymptote would be y equals -1. The initial value, or the y-intercept, is 3. The base, 1/2. So it's decaying. That graph is going down. It's decaying, decrease. The asymptote would be y equals 1. Initial value, 1/2. So that's where it crosses the y-axis. The base is 3. It's larger than 1, so it's growth. And the asymptote is y equals -1. All right. So pulling all those things together just to help you with the visualization of it. If your graph is going up, when you read it from left to right, that would be growth. And the asymptote is that little bottom line where it doesn't quite cross, right? That would be your asymptote. If your graph goes down when you're reading it from left to right, that's decay. And again, you're going to have that asymptote pulling it closer and closer to it. All right, I hope you're feeling good with this stuff. Head on over to quizzes.com, joinmyquiz.com, type in the code, and get some practice in. Top 5 winners, you get a choice of any candy you want. I'll even have it shipped to your house. Miss you guys.